All right, so today we're starting chapter 5. We broke up 5.1 into 4 sections, so this is going to be the first section, and we're going to focus in on parts of a triangle. So the first part is angles of a triangle, and there are 4 types. The very first type is our acute triangle, and the definition of our acute triangle is that we're going to have all 3 angles less than 90 degrees. So you can see each one has a tiny angle. The way I like to think about this is my reference. And my reference is always going to be my hand, making that L shape. That L shape distinguishes a right angle. Anything smaller than that L shape would be an acute angle. And anything larger would be a different type, which we're going to get into. All right, so here again, everything less than. So all 3 need to be less than, and that would classify as acute. The next one is we have obtuse. An obtuse angle, or obtuse triangle, is where we have one angle greater than 90 and less than 180. So looking in this diagram, this is where that angle would occur in this picture. Sometimes it can happen in any of the locations, but here it's this angle. I could see that it is larger than that reference angle I make with making that L in my hand, and we would classify that triangle as obtuse triangle. The next one is we have our right triangle, which we've heard about already. So our right triangle, we have distinguished with that box. Remember, that's our notation for 90 degrees. Sometimes it will have that box, sometimes it will not. It may have a number of 90, or it might have information provided in the given where you know a 90 should be placed there. So make sure you're paying attention to all the key information. And then last but not least, we have equiangular. So equiangular, in the title itself, equal. So it means that all 3 angles are congruent. And to show congruent, if you remember, we put our curve markings to show congruent. Each one of these angles here is 60 degrees. So in an equiangular triangle, every single time, all the angles are 60 degrees. All right, so let's look at our first 3 examples using these terms. So in our first example, in letter A, we have 3 angles given in triangle KLM. The first thing I see right away is I see 90 degrees. So right off the bat, I can conclude that this triangle is going to be considered a right triangle. It doesn't matter that these 2 are smaller than 90. Because I have one angle that is 90 degrees, it automatically is classified as a right triangle. So then moving on to the second example. Again, looking at all 3 angles, we have 30, 30, and 120. 120 draws my attention. This is greater than 90. And since it is greater than 90, we're going to classify this triangle as an obtuse triangle. I always think of obtuse triangles like a large angle. Try to make sure you're remembering the best way possible to be able to classify your triangle. And then our last example, we have 26, 60, and 92. My focus goes to the 92. So since it's not 90 degrees, I can't call it a right triangle. It's greater than 90, less than 180. So we're going to call that our obtuse triangle again. Remember, to be an acute triangle, all 3 angles have to be under 90 degrees. All right, going into the second part of triangles, we're going to be looking at length or side length. So the very first one is scalene. So scalene means that no 2 sides are congruent. And I can show that on the diagram using my tick marks. So the way I can show that is if I give one side 1 tick mark, another side 2 tick marks, and another side 3 tick marks, that means all the lengths do not match. Not one side matches in value. So again, that's our scalene. Sometimes you will see a diagram that will look like this, or you may see that it will have all different lengths in number value, which means it will still be scalene, or it will be just a picture like you saw without any markings whatsoever and no value. But you can clearly see that all 3 sides do not match in length. Our next example, we have 2 tick marks here, which means those 2 sides are congruent. And in our definition, we're going to call this an isosceles triangle, which means at least 2 sides are congruent. And here you see we have our 2 sides congruent with the tick marks. Then our last one is our equilateral triangle. Here you see that has 3 tick marks. I'm just making them darker so you can see them. It means that all the sides are congruent, all 3 sides. So when we have an equilateral triangle, every side will be the same value, or it will have the same number of tick marks all the way around. Now having that information, we're going to classify the next 3 with the terms for sides. Before I do that, what I do like to do is use my knowledge of tick marks to add to my picture. This will help us in the future with other problems to come. So in the first piece, I can see in letter A, we have 4, 4, and 5. I'm going to put tick marks to the sides that match. So I have a pair of sides that match, which means that I have an isosceles triangle. All right, in letter B, we have 3, 3, and 3. So I'm going to put a tick mark on each side. So here all the sides are congruent. So I have an equilateral triangle. All right, and then the last one, it shows that we have tick marks. I'm just going to draw over them so you can see them a little more clearly. So we have 1 here, 2, and 3. Again, that means all the sides do not match. And since they do not match, we are going to call them a scalene triangle. All right, so I want to recap our vocabulary for our next 3. So we have sides and angles. So briefly, here is our angles. We have acute, obtuse, right, and equiangular. And we have our sides, scalene, isosceles, and equilateral. So remember when we classify triangles, we are capable of labeling them with angles and sides. So you should have 2 words for each triangle. And we're going to use these words in the next 3 examples. So again, make sure you do have these words down and you understand which ones are for angles and which ones are for sides. All right, so number 1, notice I took away all the side lengths, all the numbers, all the tick marks. We really don't need them. We can use what we know to properly label them based on angles and sides definitions. So in number 1, looking at the sides, do any sides match? And the answer is no. So since it is no, I'm calling it a scalene triangle. But I'm not done. I have to address what it is by an angle. So again, this is sides, and this is going to be for angle. All right, so looking at my angles, my attention kind of goes to angle Q. So remember, I make that reference angle using my hand, and if it makes an L, it's 90. If it's greater than, it's obtuse. If it's less than, it's going to be acute. That angle Q is a little bigger than making my L, so this we're going to classify as obtuse. So which means that that is greater than 90 degrees. I know it might be a little challenging to see, but again, this is just for practice and we're going to try more of them. Number 2, do any of the sides match? And the answer is no. So again, this is another scalene triangle. And then we're going to look for our angles. So I can see that angle B and angle A are very small. They're acute. So I need to look at angle C. Angle C actually makes that perfect L. So I'm considering this to be a right triangle. And then the last one, right off the bat, we see the 2 tick marks. I'm just making them a little darker. And since they have 2 tick marks, what name can we give this triangle? Right, we're going to call that isosceles. And now that it's isosceles, I can see that this angle E, F, and G are all small. They don't make that letter L. It's smaller than the letter L. So what would that be considered? Would that be acute, obtuse, right, or equiangular? And in this case, it is going to be acute. All of them are less than 90 degrees. All right, continuing on with side lengths. we are going to use some information. So here we have our side lengths now with some form of algebra where we're going to solve for our missing variable. The first thing I see is that we have perimeter given to us. And because we have perimeter given to us, we can remember that perimeter is when we add up all our sides to equal the perimeter amount. So I'm going to create that equation. I can start from any side, it doesn't matter. So I have y plus 3 plus 2y plus 6 plus 3y plus 8, and that's going to equal 137. Again, that's from our perimeter we set it equal to. Now I'm going to go back and combine like terms on my left-hand side. So I'm going to circle all my variables. When I do that, you can see that I have 1y, 2y, and 3y, which makes 6y. My constants, I'm going to add them up. I have 3 plus 6 plus 8, which gives me a total of 17. And now I can solve my equation to get y by itself. So I'm going to subtract 17 from both sides. And then I'm going to divide by 6. So y equals 20. So again, you can see that I made my equation, used my perimeter to solve for my variable. I'm going to use my variable now to help me solve for the rest of the triangle. What we're going to do is we are going to plug in, y into our lengths. Now remember, we solved for y. Y is 20. So I'm going to start, again, anywhere on my triangle. I'm going to start with AB. So AB, that expression is y plus 3. So AB equals 20 plus 3. Okay, I'm putting parentheses around to show that substitution. So AB is then 23. So I'll fill that in right there. All right, moving on, I'm going to go to BC. So BC is 2y plus 6. So again, we're going to substitute in. So 2 times 20 plus 6. So 2 times 20 is 40. Add that 6, it gives me 46. And then we have the last one. I'm just going to change the color so you can still follow it. Let me circle those answers. So AC is 3 times 20 plus 8. So then when we multiply, we have 3 times 20, which is 60. Add 8, we have 68. So AC is 68. All right, so again, that was all using from our information of knowing how to use the perimeter and creating that equation to solve for y, and then use substitution to help us. All right, and now we're going to see one more variation using the lengths to use our variables. All right, so the first thing is we have a clue on this diagram. The clue on this diagram is that we have tick marks. In this case, we don't have perimeter, so we have to use what we have. So that clue is tick marks. So I hope we remember at this point in the game that we know that tick marks means we have congruent lengths or equal lengths. So on my diagram, I'm going to circle where I have my congruent lengths. So that means that 18 and 2y plus 8 need to be the same value. So that means BC is the same length as AC. And the equation I can create for that would be 2y plus 8 equals 18. Again, we're setting them equal to each other because they are the same value. So now I'm going to solve my equation. I'm going to subtract 8 from both sides. And then I'm going to divide by 2. I'm going to get y equals 5. And now we're right back where we left off in the same situation. We need to find our lengths, so we're going to use substitution again. So we're going to plug in. Now, what I like about this problem is some of it's already finished for us. We already know BC is 18, so I'm just going to fill that in. But we also know AC needs to be 18, so I'm going to fill that in as well. You can solve for AC. You can plug in and use your substitution, which I will show, but you really don't need to. As long as you know that it should be the same, you're already done. You have one less piece to fill in. All right, but I will show AC. So here is AC. So 2y plus 8. And we're plugging in our y. So we have 2 times 5 plus 8. And that is 10 plus 8, which is 18. All right, and then our last piece is AB. So AB equals 3y minus 4. Now we're going to plug in. So AB equals 3 times 5 minus 4. So now we have 15 minus 4, and that is going to be 11. All right, so that's it for this lesson. Again, to recap, make sure you know your vocabulary for your angles on the interior and your vocabulary for your lengths for the sides of a triangle. And we're going to continue practicing with this lesson. Talk to you guys soon.